All right, everyone. We are starting section 1.5, solving inequalities. So, first thing is review. Write an I next to the sentence if it's an inequality, or an E if it's an equation. Well, equation, you got the equal sign, and inequality were the symbols that kind of look like little alligators. Those less than, greater than, or less than or equal to, greater than or equal to. So, if I see the alligator, that is an inequality. This one is a greater than symbol. This one is 45 is less than 46, another inequality. This is actually neither an inequality or equation. That's actually the not equal to sign. So that's a tricky one. This one is an equation here. Okay. Complete each sentence with the less than, greater than, or equal to symbol. 9/2. What is that? That is about, it's like 4.5, right? That's definitely the greater than 4. Let's do some math here. What is this? 2 plus 3 is 5. 5 times 5 is 25. That is not as big as 27. That's less than it. 0.6 repeating, or 2/3. I believe 2/3 is also 0.6 repeating. That's actually equal to each other. And then any negative number will always be less than a positive number. Okay, moving along. A compound is made up of separate parts. A compound inequality is made up of two or more simple inequalities joined by an and or an or, if you can read that. So not only will we be looking at inequalities today, but we'll look at compound ones. Like there'll be two inequalities in sort of one sentence. All right. A student uses the word compound in 3 different sentences. Place a check mark next to the sentences that use the word correctly and use an X to those that do not. So in chemistry class, we learn about various chemical compounds. That's a correct way to say compound in chemistry class. A compound inequality contains more than one inequality symbol. We just talked about that up here. That's true. To simplify an expression, you can compound like terms. That's not really the right way to say it. We'd say combine like terms. So that's not really the right way we use the word compound. Number 7. X is at most 25. Now we're taking and writing. So if you remember what at most means, if I give you at most $20, I could give you 20, or I can give you less than 20, right? I can give you 15 and say I gave you at most 20, right? So X is less than or equal to 25. I can give you 25, or I can give you less than 25. X is not equal to 25. That's just that little not equals to symbol. If we have X is greater than 25, then the alligator eating X, because it's bigger than 25, it's greater than it. X is less than 25. That's just X is now eating 25 because X is smaller than 25. Okay? So this could be a tricky one. So at most would be this symbol. At most is the less than or equal to. If we said at least, if we said something like that, then that would be the greater than or equal to symbol. If I have to give you at least $25 to go to the movies, then I have to give you 25 or more, right? Or you won't be able to get in. Okay. Moving on. Problem 1 up here. What inequality represents a sentence? The quotient of a number and 3 is no more than 15. So the quotient of a number and 3 would be division with the number on top. Okay. So which one is no more than? I can give you no more than. That would be less than or equal to. Okay. I can give you $20 or less than it. I gave you no more than $20. Sometimes it's easy to think about money. So write the inequality. The number divided by 3, the quotient of the number in 3, is no more than. It's less than or equal to Uh, what number is it? Oh, 15. It's up there. 15. Got it. So now we can solve inequalities. So pretty much, the rule of thumb is you just solve it how you normally do. The only thing you got to remember is if you ever multiply or divide both sides by a negative, that is that spot where that inequality flips. Okay, that's the only thing different between an inequality and an equation. So what is the solution? Well, we have a distributive property here. So negative 2 times x is negative 2x. Negative 2 times 9 is negative 18. Plus 5 greater than or equal to 3. Combining like terms, we get negative 2x. What does this become here? That is now negative 13 is greater than or equal to 3. I'm going to add the 13 over. And I'm going to move up here. So negative 2x greater than or equal to 16. So now, this is that warning I gave. We are dividing both sides of an inequality by a negative. Okay? You're allowed to do it, but what happens is these cancel. The inequality, it was a greater than or equal to, now it's a less than or equal to. The inequality flips. Okay, be careful. This is a negative 8, and this is our answer here. Okay? So what does this mean as our answer, really? The graph that we're going to graph in a second includes every number that is less than negative 8. Okay? The graph will have a closure open. So when we graph inequalities, wherever we start on the number line, that kind of like starting point, we need to make sure we open or close the dot if it's included or not, and as if it's a part of the solution. So you look and say, okay, is negative 8, the number itself, a part of the solution? Well, because it says or equals to, that means it is a part of the solution. So that means we are going to close it. Closed. It's kind of like, I sometimes think of if you understand that or equals to means it's a part of the solution, but you don't remember if it's closed or open. Think about like an invitation list. If you have boxes next to people's names and you're saying I'm inviting this person, I'm including them, right? I'm closing them in. So where's negative 8? You are over here. We're going to do a close dot. Close dot, because negative 8 is coming to the party, the graphing party. And now less than means we're going numbers less than this. They tricked us in thinking we were going to be using all this graph, but we're not. Less than means numbers like negative 9, negative 10, this away. We just kind of shade in the number line here. Okay? Moving on. Using inequality for a word problem. So, a digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee, but only charges 50 cents per download. How many songs must you download for the second plan to cost less than the first? So if you are only downloading one song, paying $25 membership fee is a lot more than the $9 membership fee, right? But if you're downloading lots of songs, the 50 cents per download, might eventually be cheaper than the $1. Okay, and maybe not might, but it will be cheaper. But the question is, how long? How many songs do you need to download? So let's let what are we going to use here? Songs. I like to use the letter S. So why don't we use? I'm going to use an S for song. S is the number of songs downloaded. C1 is be the cost of the first plan. C2 will be cost of the second plan. Okay. Let's move on to the next one. Not the next one, but the next page. We're still on the same problem. So, the cost of the first plan, it was $9 plus $1 per song. The cost of the second one was $25 plus 50 cents per song. So right inequality represents the situation. So we are trying to figure out at what point will the $25 one, we're trying to figure out when is C2 less than C1. That's the question we're trying to figure out, okay? Because obviously C2 is currently costs more than C1. 25 plus 0.5 S. When is this less than 9 plus S? I'm going to lose the 1 because we don't need it. Well, let's solve it. I'm going to subtract 0.5 S to both sides. Okay. At the same time, I'm going to subtract a 9 to both sides. Okay. These 9's cancel. These 0.5 S's cancel. 25 minus 9 is 16. I'm going to go do my work over here. Less than. If I have 1 S and I take away 0.5 S's, I'm left with 0.5 S. Okay. And now I'm going to divide both sides by 0.5 to get rid of it by my variable. And what is 16 divided by 0.5? If you remember, dividing by 1/2 is actually the same thing as multiplying by 2. So 16 divided by 0.5 is actually 32. Okay. So here is the thing. We have the number of songs has to be greater than 32. That's what this means, okay? Songs needs to be greater than 32. So that means is technically we have to download 33 songs before the plan is actually cheaper, okay? If we did get 32 songs, the plan would not be cheaper, okay? For it to actually be cheaper and cost less, technically we would have to go one more song, okay? This is 32 is actually the break-even point here. This is where they are equal to each other. All right, moving on. Looking at no solutions or all real numbers as solutions. So every now, just like when equations, you can get like the funky answers. It can happen for ones like this. So it's not going to happen too often. I might throw in like one question like this or two. You know, not doing a lot of these, but just to show you what happens. Let's say we have this problem here. We're solving it, and this happens. So we do distributive property. We get 8x minus 12 is less than 8x plus 8. Okay, multiply inside. Let's say I want to subtract 8x from both sides. I'm getting my variables all on one side. Okay. And we wind up with all the variables canceling out. And we get negative 12 is less than 8. Okay. Well, you know, that's always true. Okay, negative 12 is less than 8. That is always true. And so that means like it's kind of like we have infinitely many solutions. That's, maybe you said that in Algebra 1, maybe. Infinitely many solutions. Or we also sometimes say all real numbers. All real numbers is technically a little bit more specific. Sometimes we use that cool looking R, if you've seen that R before. Okay. So when would the other play? Because I think we just move on. So that's always true, right? If we end up having like 2 is less than 0, well, that's not true. That would be a never true. Okay, if this had happened, then that would be a never true. We had something that was true, so that's always true. Infinitely many solutions, all real numbers. Okay. Um, this would be like the no solution version. Okay. And then if we do get an answer, then that's the sometimes true. Okay, like everything we've had so far was a sometimes true. Um, moving on. Where are we at on time? I can't see. 15 minutes. Okay. We're almost done. Solving this one was the solution. We have an and now. Okay. So we have two different inequalities separated by an and. So what you do is you solve them separately. Okay. So I'm going to take this first one and I'm going to solve this first one. So what would I do? I would add 1 to both sides. So I've got a 9 less than or equal to 3x. I'm going to divide both sides by 3 and get 3 is less than or equal to x. Okay, that is one answer. I'm also going to solve this one. I'm going to rewrite it over here. 2x less than 12. Divide both sides by 2 and get x is less than 6. So I have, I like to usually look at it with the x on the left side. It's not a big deal. X is greater than or equal to 3. These are the same thing. So we have x is greater than or equal to 3, and we have x is less than 6. Okay? So we're not going to worry about graphing. We're not going to be graphing the compound inequalities. Okay? We're not graphing. But what we can do is rewrite it as a compound statement. Okay? So with our and, because there are numbers like in between 3 and 6, right? We can say our x is literally in between 3 and 6. X is less than 6, and at the same time, the x is greater than or equal to 3. And this is sort of another way that we can write and statements. Compound, okay, without actually using the word and, okay? Now, again, this is not wrong. This is not a wrong statement, okay? These are the same thing, just this is kind of like shorthand, okay? And sometimes I might ask you to take this and rewrite it with the compound inequality, okay? I think there's one like that on the Math Excel. You solve it and then you write it like this on Math Excel, okay? You just literally put it in between the two numbers. Note that the alligators are always opening to the right here. So you got small number is less than the x, and the x is less than the big number, okay? X is in between those two. You'll never write one of these with the alligator going that way, okay? Or the alligators not facing the same way. Whatever you do, the alligators need to be facing the same way. Okay. Last one. Now, if we have an or, okay, same idea, you solve it, but you just leave the or. There's no fancy way to rewrite an or. So here, I'm not even gonna bother with all this stuff. Again, we're not graphing. Okay, I'm not gonna bother with all this stuff. I'm just gonna solve them off the side. So 7w plus 3 is greater than 11. I'm just gonna solve it. Minus the 3, minus the 3. 7w is greater than, what does that become? 8. And then if we divide both sides by 7, we get w is greater than 8 over 7. Not too pretty of a fraction, but there's nothing to do. We didn't make mistakes. We're good. So that we have this, or we have this one. I'm going to solve this one too. I'll solve it down here. 4w is less than 1, or sorry, minus 1, less than negative 13. We add the 1 over to get negative 12. And now we divide both sides by 4 to get w is less than negative 3. Okay? No flipping here because we didn't divide by a negative. We divided by a positive 4. Okay, so our answer is w is greater than 8 over 7, or w is less than negative 3. Okay, this is like our answer here. Okay, there's nothing really to say or to do like we did with the and. And that is it. That's it for today. So head over to the Math Excel now, and got about 10, maybe I think 11 problems on there to do for homework. I actually made it due Monday this week instead of Sunday. So there you go. Have a good weekend, everyone.